All right, so today we're going to talk all about radian measure of angles. And at first, it might seem kind of weird, but from here on, throughout all the math classes you're going to take, you're not really going to look at angles in terms of degrees. I'll maybe say degrees like 3 or 4 times today, and then the rest of the year, it's just going to be radians. But for a reminder, yesterday we talked about angles being graphed in the coordinate plane. And an angle that is in standard position is an angle like this one, where the vertex is at the origin. There's a ray pointing in the positive x direction, and then a terminal ray after you rotate around. Right? This angle is in standard position. Now, one thing you may not realize is that angles can be negative. So the positive rotation is like this, going around the axes, like they're ordered, the quadrants 1, 2, 3, 4. That's a positive rotation, but there's also a negative rotation. So if we start the positive x-axis and we rotate around clockwise, that's considered a negative angle. All right, this one that's graphed is a positive because the rotation is counterclockwise. All right, and then we can think of angles having a periodic behavior because they're rotating around. And angles in standard position that share a terminal ray, they are going to differ only by integer number of revolutions. So that's a weird kind of way to say it, and we'll talk about this some more. But those are called coterminal angles. They're going to have the same starting and stopping points. So they're going to start here and end here. One of them could rotate this way, and then the other one could rotate in the negative direction, and that would be a coterminal angle. They are different angles. Like, this one has more of a rotation than this one. But if they start and stop at the same place, they're considered coterminal angles. Okay. So, like I said, we are going to measure angles in terms of radians. And to figure out how many radians an angle is, what you can do is take the arc length, so the length of the rotation around the circle, and divide that by whatever the radius is. And that gives you the angle in terms of radians. All right, and then just a reminder, we're going to use this in a second. If we wanted to find all the way around a circle, the circumference of a circle, that is found by 2 pi r. We're going to use that on the back real quick. All right, so just a reminder of what we just said. Radian measure is equal to the arc length divided by the radius. All right, so what we're going to do is graph and find the given angle and measurement in radians. And there's more than degrees and radians to measure angles. Angles are also measured in revolutions. So each one of these angles are measured in revolutions, and we're going to change that measurement to radians. All right, so we have this angle that is 1 full revolution. So let's graph 1 full revolution. It's going to be like this. I'll try to do it. It's not great. All right, so we want to change that 1 revolution to radians. So a full revolution is a full circumference. Now we don't know what the radius is. So how can we represent a full circumference? 2 pi r. So a full circumference is 2 pi r. And we're going to divide that by whatever the radius is. And what does that leave you with? 2 pi. So a full rotation is going to be 2 pi radians. Now, you don't ever have to give a unit of measurement for radians. You just say 2 pi. That's what makes radians so nice to work with, is you don't have to give a degree symbol or whatever. All right, I feel like logically we could figure out what half of a revolution is, or rotation is. That's spelled wrong. What half of a rotation is. Just using logic, but let's go ahead and do the math. So it's going to be half of 2 pi r. That's still going to be divided by r. So what do you guys think half of a rotation is? Pi. All right, so that is alpha, which is pi. All right, and then a quarter of a rotation, I think probably logically you could figure it out, but that's going to be beta. I'm going to graph it. All right, but if we took a quarter of 2 pi r and divided that by whatever r is, what would you get for a quarter of a rotation? Half pi or pi over 2? Good. Right. All right, and then we have 3/4 of a rotation, which is going to be to here. And you might be able to just use logic to figure that out. Or we can take 3/4 of 2 pi r, divide it by r, and what should it reduce down to? 1.5 pi or 3 pi over 2? Good. Those 4 angles are called the quadrant angles because they're what separates the quadrants. And they're super important. They're probably going to be the first ones you learn. 0 radians is actually here where you just don't rotate at all. It's just an arrow ray pointing to the right, bless you. It's considered to be an angle of 0 radians. But like I said, those are going to be the first ones you learn. They're pretty easy to remember, I think. Maybe not. All right, but a 1/12 of a rotation is a little more difficult. So let's figure out what a 1/12 of a rotation is. Let's see. I need some more color, so I'll make that one red. All right, so we're going to do a 1/12 of 2 pi r. So again, the r's cancel out, and you basically get 2 pi over 12. And what does that reduce to? Thank you. So we're going to graph a 1/12 of a rotation. It would be about right here. That's going to be pi over 6. And that angle is going to be theta. So pi over 6 is considered to be a special angle. It actually correlates to 30 degrees. If we were talking about that angle in terms of degrees, so you can visualize what that would be. But I think you're going to be able to graph it without thinking in degrees. I hope so anyway. All right, so we can have angles that are similar to pi over 6 that are in the other quadrants. And that's what we're going to do on example 2. And this is important. This lesson is so important for what we're going to do later that I don't know. I just really want you to focus on it. So what we have here is this is the pi over 6 angle that we just graphed. And each one of these angles is pi over 6 radians away from the x-axis. And so we're going to figure out what their measurements are in radians. All right, so before we do that, what is the angle from here to here? In radians. Half a rotation is pi. Good. All right, so what we want to do to figure out Q is to go from here to here. All right, so I know this whole thing is pi. I know what is this angle right here from the x-axis? Pi over 6. So what would I do with those two things to get that angle? Subtract. So I'm going to take the whole pi and I'm going to subtract away the pi over 6 that I don't want, and that should give us Q. Sorry, my Apple Pencil just needs to be charged for longer than 5 seconds. That's all we got. Okay. All right, so you guys are getting super great at subtracting and adding fractions. But to be able to do this subtraction, I need to have a common denominator. What's it going to be? Yes. So how can you write 1 pi as something over 6? 6 pi over 6. So 1 whole is 6/6. Right, and then when I subtract, I'm just going to subtract the numerators, and you should get 5 pi over 6. That is Q. All right, for R, I still know that here to here is pi. I still know that this is pi over 6. So what do I need to do this time to get that angle? We're going to add. Nice job. All right, so I know R is 7 pi over 6. All right, and then what was a full revolution? 2 pi. All right, so I know here to here is 2 pi. I know this is pi over 6. So what do I need to do to find that? Subtract. All right, so this time 2 pi is going to be 12 6 pi, bless you. All right, so those are the 3 special angles that are related to pi over 6. I guess that correspond to pi over 6. All right, there are 2 other special angles, and they're going to be pi over 4 angles and pi over 3 angles. And your first 2 problems to do on your assignment are to do these things for pi over 4 and for pi over 3. And I know it's going to seem tedious, but it's so important for what we're about to do. I really need you to do it for me, please. All right, now once you kind of figure out where they lie, the pi over 6, pi over 4, and pi over 3 angles, then they make it a little easier to graph them. So multiples of pi over 6 are going to they are going to correlate to 30 degrees away from the x-axis, and so they're going to be graphed closer to the x-axis. The angles that are multiples of pi over 4 are going to correlate with 45 degrees. And so where do you think they would be graphed in relationship to the x and y axis? Say it again? In the middle. So they're exactly between x and y axes. All right, and then multiples of pi over 3 are going to correlate to 60 degrees away from the x-axis, so they are going to end up being graphed closer to the y-axis. Right, and that's probably the last time you're going to hear me say degrees, unless I'm talking about the temperature. All right, so just knowing like where they're going to fall, closer to X, Y, or right in the middle, is one way to help you learn. The other thing you're going to need to know is what quadrant the angle falls in. And to do that, you use the quadrant angles. So this is 0, pi over 2, pi, 3 pi over 2, and then a full rotation is 2 pi. Right, and then I know some of you, it's easier for you to think in decimals. I'm trying to help you move over to the good side where the fractions are. But if you're thinking about decimals, you could also think of it about this as 0.5 pi. Oh, goodness. And then for 3 pi over 2, you can think about that as 1.5 pi. All right, so on example 3, there's a whole bunch of words. And so we'll read them, and then I'll tell what you're really looking for. So theta is an angle in standard position whose terminal ray intersects the circle centered at the origin at a point P. If P is in quadrant 2, which of the following angles could be theta? And we're going to graph theta. So all this really is asking is which one of these angles is in quadrant 2. And so you're trying to figure out which ones fall in between half of pi and pi, or 0.5 pi and pi. So if we're looking at the fractions here, which one of those falls between half of pi and pi? B, 3/4 of pi. That's the only one that's in quadrant 2. So we're going to graph it. It is a pi over 4 angle, and so it's going to be an angle that is, you try to graph it directly between the axes, and then that's going to be point P. All right, and I'm also going to do the little swoop. It's a positive angle, so it goes counterclockwise from 0 radians. All right, for example 4, we're going to let beta be an angle in standard position whose terminal ray blah, blah, blah. We really just want to know which one of these angles is in quadrant 3. So we're trying to figure out which one falls in between 1 pi and 1.5 pi, or 1 pi and 1.5 pi. What do you guys think? A. So if you're thinking in terms of decimals, right? Well, in fractions, that's 1 1/3. 1 1/3 is between 1 and 1.5, or is 1.333. So it's A. It's okay. All right, so we want to graph a pi over 3 angle in quadrant 3. So pi over 3 angles are always going to be closer to the y-axis. So draw an angle closer to the y-axis in quadrant 3, and that's going to be point Q. And it was a positive angle, so we're going to do swoop that way. All right, and then for 5, we're looking for which one of these angles is in quadrant 1. I do have a little typo here. That should be alpha, not theta, but it's fine. Okay, quadrant 1, in terms of positive angles, is going to be between 0 and half pi. So I have 2 positive angles here. Are they going to be between 0 and half pi? No. So it's definitely not those. So it's going to be one of the negative angles. And so what we're going to do to help us know where it falls is we're going to find their coterminal angle. And to do that, you add 1 full rotation, or you add 2 pi to it. All right. So that angle is going to fall in the same place that 11 pi over 6 would fall. Is that going to be quadrant 1? Definitely not. So it is going to be C, but let's go ahead and look at it exactly just to make sure I didn't mess something up. So we're adding a full rotation to it, and I do get pi over 3. All right, so we are going to graph a pi over 3 angle in quadrant 1. So it's going to be closer to the y-axis. That is going to be point R. Is it going to go like this? No, it's a hint because I did it in red. So it is not going to go like this. So the angle we're graphing is negative. Where is it? It's negative 5 pi over 3. So we start at 0 radians and we rotate in the negative direction. All right, so draw your swoops. They're important. It doesn't feel like they are, but they are. Okay, and then I just want to make another note, and I'm going to drive you crazy about this, but these are like negative pi over 6 and 11 pi over 6 are not the same angle. They're coterminal angles. Same thing with negative 5 pi over 3 and pi over 3. They start and stop at the same place, but they take a different direction or a different route to get there. All right, and then the last thing we're going to do is graph some angles. All right, so we're just going to start off, and we're going to graph pi over 3. So there's two things we have to figure out. Is what quadrant it's in, and is it closer to the x or y or right in the middle? So what quadrant is it in? Quadrant 1. What is it closer to? The y. And then we also need to draw our direction of rotation. All right, what about 7 pi over 4? Okay, so let's look at it. So this is going to be, so for it to be in the second, it would need to fall in between a half and 1 pi. So that's way too big. For it to be in the third, it would be between 1 pi and 1.5 pi. And then for it to be in the fourth, it would have to be between 1.5 and 2. That's where it is. So what you would do, if you can't do it in your head, it's fine. You take 7 and divide it by 4. So it's about 1.7 something. So it's definitely in quadrant 4. How's it going to be situated in quadrant 4? Halfway, yep. And it's a positive rotation. All right, and then for C. So we know what pi over 6 looks like, I think. It's this one. It's a special angle, one of the first ones we graphed. That's a positive pi over 6. So what is negative pi over 6 going to look like? Good. It's that same space that was rotated, but it's rotated in the negative direction. So that's negative pi over 6. All right, so now the last one we're going to do is 11 pi over 4. If I take 11 and I divide it by 4, is that going to be something between 0 and 2 pi? No, it's bigger than 2. So 11 divided by 4 is bigger than 2. So what I need to do is find a coterminal angle, kind of like what I did here. But what do you think I should do with the 2 pi? Subtract it. Very good. So that's going to give us 3 pi over 4. What quadrant does 3 pi over 4 fall in? Quadrant 2. Halfway, right? All right, so you guys draw the loop that you think it will be the loop for 11 pi over 4. All right, so we should go in the positive direction, but we do a full rotation and then a little bit more to get to 11 pi over 4. Those two are coterminal, not the same angle. All right, so I'm going to give you all your assignment. It looks like it's really, really long, but that is only because the problems take up a bunch of